All right, so how to find the missing potential kinetic energies, velocities, or heights at various locations for a conservation of energy problem. You got to go to a point where you can figure out both potential and kinetic. If you are able to do that at one point, the mechanical energy of that system remains constant, though you'll have all of these. You'll have enough information to then find one of these two, and then to find the missing, you can just subtract. To find velocity, you can use this equation, or if to find the height, if you know what the potential energy is, you can take the potential energy divided by mass times gravity to find the height. So I don't have the height here, but I have velocity, so I can find kinetic energy here. I can't find potential there. I know that right here at point 3, the height is 0, so I definitely can find potential energy. We don't know what the velocity is, so I can't find that yet. I can't find this yet. I know the height here at point 2 is 3, so potential energy I can find, but I don't have the velocity, so I can't find that. At the start of a roller coaster, at point 1, they tell us the velocity is 0. So with that, I definitely can figure out the kinetic energy. It would have to be 0. And I have the mass and the height here, so I can also find potential energy. So you need to start at point 1. So at point 1, we're going to take the equation mass times gravity times height. Mass times gravity times height. The mass is 50. For gravity, we're using 10. H has a height of 4 meters. So with that, we're going to multiply all of these together, and you're going to get 2,000 joules. So the potential energy at point 1 is 2,000. I don't even need to do work because I know that if the velocity is 0, the kinetic energy is 0. If you needed to actually see it, the kinetic energy equation is 1/2 mv squared. So 1/2 times 50 times 0 squared, it's 0, so it doesn't matter. Now that I know both of these at this point, if you write, now I can just use this equation. I add them together. So 2,000 plus 0 is 2,000 joules. Cool. So once you know this, the mechanical energy is constant throughout. So right down here, you can just go down and say 2,000, 2,000, and 2,000. They also wanted to know what the velocity was at point 1. Well, they already gave that to us. That was 0. So perfect. Okay, now let's move on to the next point. At point 2, we don't have velocity, so we cannot use this equation to find kinetic energy, the 1/2 mv squared. But we do have the height, and the mass hasn't changed, so you can find the potential energy at point 2. So again, potential energy, mgh, 50 times 10 times 3. This came out to be 1,500, and that is 1,500 joules. Cool. So remember, mechanical energy is the sum. It's the addition of both potential and kinetic. Since that is 2,000, 1,500 plus blank has to equal this. If you know the number off the top of your head, awesome. If not, you can take the mechanical energy minus the potential energy. So 2,000 minus 1,500, that's going to give us 500 joules of energy there. Cool. Now, to find velocity, you need to take 2 times the kinetic energy divided by the mass and then square root it. So for part 2, 2 times 500 divided by the mass of 50 and square root this. comes out to be 4.47. All right, so you have part one or point one done. You have point two done. Now right here, all right, we didn't know what the kinetic energy was because we didn't know the velocity. But if you're just looking at this, the height here we're assuming is 0. So we know that that is 0 because even if you did mgh 50 times 10 times 0 is 0. All right, so I know it's just 0. Boom. Didn't really need the math there for that one. Well, 0 plus blank has to equal 2,000. So again, don't really even need to do math as long as you understand that concept. That one's a little easy. If you still needed to, you could do mechanical minus potential, but 2,000 minus 0 is 2,000. Cool. So now that you have the kinetic energy here, you can use the equation 2 times kinetic energy over the mass and square root. So you're doing 2 times 2,000, divide that by 50, and then square root. So if you're using this calculator, all right, you can do 2 times 2,000, good, divide that by 50, good, and then to get to the square root on this calculator, you can just hit second, x squared, and then I know the number was 80, but if it's a small, a larger number with a bunch of decimals, you can just hit, all right, you can just hit second, and then right down here with the negative sign, because in yellow for the second piece, that's answer. So it takes your last calculated, all right, your last answer from your last calculation. So I hit that. All right, and we get what? 8.94. So 8.94, and the velocity unit is meters per second squared. All right, so we've got points 1, 2, 3 complete. Now for point 4. For point 4, we don't know what the height is, so we cannot figure out the potential right now. They did give us velocity, though, so you can find out the kinetic energy. The equation for kinetic energy is 1/2 mv squared. If we zoom in here, 1/2 mv squared. So you got to take 1/2 m, which was 50, times 6 squared. Let's throw that into the calculator. All right, so you got 1/2 times 50 times 6 squared. All right, so sorry, let me 1/2 of 50 times 6 squared. And this is going to give us 900. Okay, so we still don't know what those are. We still don't know potential energy because we didn't know the height. But again, remember, potential plus kinetic have to add up to the mechanical energy, the total energy here. So what plus this is going to give you that, or you can subtract the two. 2,000 minus 900, and you're going to get 1,100 joules as your potential energy. All right, just about done. Now, okay, well, we want to know, what the height is. How high would the roller coaster cart be at that point? So to find h, you can take the potential energy divided by mass times gravity. So for that equation, you're going to take 1,100, because that was your potential, and you're going to divide that by mass. The mass was 50, and what is gravity? Gravity is 10. So take 1,100, divide that by 50 times 10, close it, and you should get a height of 2.2 meters. Okay, so these should be all the numbers that you needed to solve before. And really, again, the process goes from figuring out what point usually is the start, because if you're given the height, mass, and you know at the start it's 0, potential 0, I'm sorry, kinetic would be 0 because velocity is 0. You have enough to find potential, add those two together, get mechanical. Then mechanical is the same. You're going to be given enough information to find one of these two. All right, so for part 2, they gave you the height, so you did this, 1500. Then subtract this minus this, found that. The next one, they gave us a height of 0. Okay, so I know that's 0. So 2,000 minus 0 would be 200, or 2,000. Boom, done. Again, here they didn't give us height, they gave us the velocity. 1/2 mv squared gave us this. Blank plus this had to be given here, so you subtracted 2,000 minus 900 to get 1,100. And then the last parts of it were to find the velocity. Okay, you do 2 times the kinetic energy divided by the mass and then square root. Or if they needed you to find height, you take the potential energy divided by mass times gravity to get your final answers.